continuing on with our bleachers system, we now have the stadium complete. Let's go ahead and turn our attention to the benches. We need benches for our characters to sit on. We're not going to have a lot of control with these benches, but once you've seen how we're setting it up, it's going to be very easy. If you, the person following along with this video, would like to go back in and add some additional control, it'll be a piece of cake actually. The objective of this video is as follows. One, create what we are going to call the unit bench. The unit bench will proportionally scale with our entire stadium system. Now, once the bench has been completed, and he's sitting down here on top of our origin, we'd like to get him copied to all of the rows on the first column of our stadium. If by the end of this video we have accomplished that, we have met our objectives, let's also, by the end of this video, make sure that the benches have been rotated in such a way that they are following along with the angle of this first column. Now, we're not going to worry about the width of the bench in this video, meaning that the bench, it's going to be, well, however big we make it down here, which means as we work our way down our rows right here, they're going to be the same size all the way down. We'll worry about getting the width control in place coming up very soon. And with width control, that's going to be an automated thing. It's not going to be a parameter that's available for an artist to control. Again, what we're looking for is a set of benches that will properly sit on our stadium, so no matter how we set up the stadium, they will go along proportionally with it. We don't want to give the artist the ability to start scaling and controlling those, because then you could end up with some really crazy scenarios where our columns start getting very close together at the bottom. So that is our objectives of the video. Now, how are we going to do this? Well, we're going to start out by creating our bench. The bench is going to be very easy: a box, a tube, get everything positioned, merged together, the end. Now, how do we copy that guy to our first column? Well, we need a series of points to copy the bench to. So we need to come up with some sort of simple system, that will put a point at the center of each of the rows. So let's go ahead and jump over the whiteboard and take a look at how we're going to put all of this together. So starting out, let's bring up a new layer, and let's give you a quick drawing of what the bench is going to look like. So as I said, we've got a box, something like this, and then I'll just, hang on, that looks rough. Alright, that's a little better. And then up underneath it, I'll go ahead and draw through this, just so that everybody can see. We'll have a tube and another properly positioned tube, like such. Now, putting this together, we'll simply start out with a box and a tube. Now, with the box, we will use its parameters to get the correct size that we are looking for. So when we're done, we'll have that exact shape right there, so a rectangular thin box. With the tube, we will use its parameters to get our first tube positioned. Once we have that tube positioned, we can simply run it through a transform to give ourselves the next tube. So let's just go ahead and run this guy. Actually, you know what? To make this look a little bit nicer, hang on one second. We managed to have lost our pen. There we go. So we'll just go ahead and run this over to the side. So this transform will be responsible for getting this guy positioned over to the other side. And once we have all three pieces of geometry positioned, we'll simply merge everything together. So box, we'll take our first tube that's been positioned properly, and then we'll take the output of our transform, which represents our second tube being moved over. Fantastic. This gives us our unit bench. Now, how are we going to get the points necessary for us to copy this bench to? Well, if you recall, all the way back, as a matter of fact, let's go ahead and bring this up real quick. All the way back to this original profile curve that we had right here. What I would like to do is, you gotta love when that happens. What I would like to do is create a point right here at the center. If we create a point right here at the center, what will end up happening is that point will get copied all the way up like such. that point's going to be our basis for the final point that we'll use to copy everything to. Now, we've got to be careful with the point. We've got the consideration of how this entire profile curve is put together, and by adding that additional point in the end, we're going to end up with some trouble with getting this guy properly positioned. So while we need to put the point in, at some point in the network, we're going to need to take the point back out so that we don't mess up the end of the profile curve generation. So now that we know that we're wanting to get this point right here into place, we're going to revisit the curve profile and add that guy in. As a matter of fact, let me do this. I'll jump back up here, and we'll hide this guy out. So we know that we are running in the negative Z direction. So to get this point right here, Steve will simply revisit the curve node. And if you guys recall, it had a sequence of numbers in there that represented each of the points. So we had our 0, 0, 0, then our 0, 1, 0. And then for this guy, Steve will simply insert 0, because 0 in X, we're still 1 up in Y, and we are negative 0.5, because if you recall, this point here was negative 1. And that will add this point into our curve. Now, coming out of our curve node, before we continue on, I believe we had a transform next to take into account the inner radius and then our copy for all of our points. We're going to insert a node, going to insert a group node. The reason we're doing this is we want to take point number 2. If you recall, this is point 0, this is point 1, this is point 2, and finally point 3. We want to take point 2 and put it in a group so that later we can quickly get back to that one point. So we'll call this something like bench point group or something. And then from there, we know that we ran through our X form. And then from that, we ran through our copy. And our copy ended up giving us this result based on the number of rows, but now the difference is we have that point in the center of each of the rows. Excellent. Now from there, what we're going to do, and if you recall, next we were worried about getting it copied over and then all of our the last primitive delete it and our last point manipulate it to the right place. Before we do that, we're going to now branch off into two different directions, into two different deletes. So here's a delete SOP. I'll just put DEL, and we'll come off in this direction, and we'll do a delete SOP. The first guy is going to isolate our original profile curve. So isol for isolate profile curve. So coming out of here is exactly what we used to have when we were coming out of the copy down here before we went in and modified our original profile curve and added that point. So now this guy can continue branching off in the different directions to finish off the original curve. Now on the other side, coming out of here is what? Well, this delete is going to isolate the bench points. So isol bench points. Notice I'm saying points, not point, because we've copied that one point, so now we can easily pull just that one copied point out, or group of points out, by using the bench point group that we created earlier. You gotta love the power of copy.
Oh, grouping is fantastic.
Grouping. So now that we have nothing more than a series of points, so if you were to look at the data right here, it would look like this if we had 3 rows. Just 3 points that have been properly positioned going back in negative Z and up in Y. So now what we can do is move them. Why do we need to move them? Well, right now with our stadium, let me see how I want to draw this. So something like this. Hang on. Yep, nope. Line out to there. There we go. I knew something looked funny. We know that our points are sitting right here. If we were to copy our benches to the points right there, then our benches are going to be hanging out into space like such, as their pivot point is right here at the center and they are sitting on top of the construction grid. So we need for these points to be moved, hang on, that last one's a little funky, there we go, to the center of each of the rows on the column, the first column. But how do we move these points over? How do we get that information?
Yeah, because this poses an interesting little challenge.
It does. If we were to take a look at the top, so we know we start out there, and we sweep 180 degrees over, so to about right there. So if I was to come in here and draw out, all right, hang on, that's just awful. That's a little bit better. So we come in here and we draw out some of our columns from a top view. What we need to do is calculate our angle right here so that if we were to take half of that, we would be right there. This is very easy to do because we know 180 degrees is what we're sweeping all the way over, and we know the number of divisions in the revolve was being driven by the number of columns. Well, we've got 1, 2, 3, 4 columns right here. If we were to take 180 and divide that by the number of columns, now we'll have this guy right here. So that's perfect. So what we need to do is come out of here and run this information, these points that have been isolated, into a transform node. And we're going to rotate the points 180 degrees divided by the number of columns.
And you may ask yourself, well, why are we rotating 180? Didn't we just say that we need half of that to get the center point?
Almost, because half is not exactly what we're looking for. Because half puts our points in the wrong spot, because the way we're calculating this, we're dealing with a circle. And so now we're looking at 180 degrees. Okay, so now we've just created this. Well, if we move our points along this, our points are no longer going to be centered on each of our rows where the benches need to be copied. They'll kind of be centered, but they're going to be pushed back because there's an arc that's taken place. So if we were to push our points back by just simply taking half, now you're going to see how our points are actually off center. They've been pushed back. Now, if you want to start working out the maths involved in scaling those points back in and all, you'll end up like Steve, and that's banging your head against something hard, like a brick.
But there's a much, much easier solution.
How about we simply figure our points? We know our points are sitting here, and if we were to rotate our points over that much, and we can easily calculate our angle right there, and then we average the 2 points, we'll end up, basically we end up with a connecting line, and we can get the center of that.
Which is exactly what we need, because each of these individual rows is a straight line segment.
So how do we go about averaging? Now we've got the angle, and the transform will have our points. So we started out with our points right here. So 1, 2, 3, okay? Now our points are going to exist on the other side on each of the flat rows. 1, 2, 3. Fantastic. That is what we gained. If I can... that guy didn't want to... Okay, I see. I went too far. That is what we gained from this expression right here with the transform node. So now that we have 2 sets of points, we can average them by running the output of this and coming up here and tapping off this guy and running this into a point SOP. And we can use the point SOP for all sorts of things, adding in normals, color, etc. We can also use them for manipulating the position of points. And you'll find that by default, if you take a look at the position, it's $TX, $TY, and $TZ.
Yes.
And that just basically says the points are where the points are. Well, we can manipulate that information. Coming into here, basically this guy right here is going to represent $TX, $TY, and $TZ when we look at, I'm just going to put $TX.
Cool.
Coming in on the other side, we can reference that through expression with local variable $TX2. $ty2, and $tz2.
And just out of reference, that's the same for any other local variable. On the point stop, since we have the two inputs, append the 2 to the end, and you're going to get the local variable, but referring to the point that's on the second input, not the first.
Exactly. So if we were to take the position information here, and we update the expression, instead of just saying $tx, $ty, $tz, to do this. So let's say for x, $tx plus $tx2, and then we take the sum of those two and divide it by 2. Since we're finding the average of just two things, that is going to give us the average in our x-axis. Now we continue doing this. I'm just going to go ahead and move this down a little bit. For $ty plus $ty2, divide it by 2, and translate y. And then finally, $tz plus $tz2, divide it by 2 in z. That gives us the average in 3D space for our points. And guess what? You're going to find our points right there in the center, which is what we're looking for. So we'll end this all off with our points being properly positioned in the center of each of our rows. So that's what we have coming out of here. Well, what do we do with that information? Well, now it's time for us to basically copy our bench to all of these points, but that's going to pose an interesting problem. Let me do the following. I'm going to come down here and say this is going to go into A. I'm going to come up here, and we're going to create our copy. You know our copy looks for two things. One, just the primitive or source information or geometry that you want to have copied. So we could take our merge for starters, and if we were to take the merge, and, man, why did I have to do that? It got all messy at the very end. And bring him over into here. And optionally, we can specify points to copy to. This will be our template, so this is where I'm going to plug A in. This will get our bench copied to all of our rows, but the orientation of our bench is incorrect. Because right now, our bench, so we've got basically starting out like here, U. Our bench is running like this. So now we have this angle that we need to take into account. We need to rotate the bench, so I'm going to draw a straight line to represent the bench. Right now the bench is going to come in copied like this. Except for, to be more accurate, it copies to each of our dots, so it's going to look more like this. Not good. So what we're going to do is we're going to rotate the bench before we even copy it, which means I'm going to need to come back in here and do a transform. And we know if we divide it by the number of columns, 180, that we get this information. So basically that allows us to calculate that angle. But we don't want the benches rotated that much to where they're sitting like this. We need halfway. So halfway between being this way and this way would give us that right there. So how do you get half of that? Well, instead of doing 180 degrees, how about we do 90 degrees? And that will give us the correct orientation. So with our transform, we'll rotate around the y-axis the data that's coming in, our bench, before it's been moved away from the origin, simply 90 degrees by number of columns. So the bench is still sitting right here at the center, but he's now been rotated. So let me go ahead and grab an eraser real quick. Switch back over to a brush. So he's been rotated around the origin in such a way that if copied over here to all of these guys, he's going to be rotated correctly. Now you may be thinking to yourself, all right, well that's fine, but then how are we going to go about rotating again for this guy, for this guy, for this guy? Well, we're not in regards to the original bench. How about we get all of our benches copied, and then we work with all of them as a group and simply rotate a copied version of that around to each of these guys. That'll be much easier to do. So we'll wire into this transform, out of this transform into the copy, and that gives us a series of benches that are not yet the correct width, but they are the correct angle, and they are all sitting on each of the rows respectively on the stadium. So that is the objective of this video, and that's what Steve's about to do over in Houdini. So you ready to jump over into Houdini, Steve?
Alright, so let's jump over into Houdini and recreate what we just saw on the whiteboard. So I'm going to start by creating the box that will become our seed.
Okay.
So I'm just going to move up to the top of the network because we've seen that we're going to branch off of our copy with our line and take that down into a copy for copy in the benches. So I'm going to build the benches up around here. We can always move them if we need to.
Sure.
I'm going to push tab and drop in a new box SOP. I'm going to rename this guy to bench box. And bring our visibility down to him. First thing I'm going to do is uncheck consolidate corner points so we get nice hard shading. I'm going to set a couple of size parameters that are going to be permanent and then one that's a temporary. In Y we're going to have 0.05. In Z we're going to have 0.75. Now talking about this being a unit bench,
yeah.
We remember that our rows, all of our rows before we scale them up, are 1 unit back in Z. So we set our bench to be 0.75 units back in Z. So it's 75% of the total row. Now X is going to be our width. And we know that we're going to need to control this based on which row it's in. For now, just so we get something that looks kind of bench dimensions, I'm going to set this to a value of 4. We will be coming back and controlling this mathematically such that it matches which row it's on. But for now, that's going to give us our bench. Now, we can't position this in Y just yet because we need to create our tubes first to know how high in Y we want to position up. So I'm going to create a tube SOP, which I'll rename to bench tube. Bring our visibility down. I'm going to create a nerves tube. I'm going to give it a radius of 0.1 by 0.1. Again, these for me are going to be permanent values. A height of 0.5, so it goes up half of our single unit because we're dealing again with the unit rows and columns and our unit bench. We do need to offset this in center Y so that it sits up on the construction plane. We've seen how to do that before. We take our height parameter, and if we divide that by 2, we'll offset to sit up on the construction plane. Now, I'm going to offset our box up in Y to sit on top of this, and then I'll come back and deal with the positioning in X of the tube. So let's jump over to the box and let's template the tube and bring our visibility to the box. We can simply offset in Y by the height of the box, and that will center us up around the top of the box. That would be fantastic for what we need. So center in Y, we can take our bench tube, take his height, and that will center us up around the top of the tube. So let's jump back down to our tube. I will template in the box so we can see the effect it's having. And if I push space 2, we can come into a top view. Although we appear to not be able to see the tube in the top view, so I'm going to jump back to a perspective view because that was crazy. Okay, so I'm going to deal with center in X. Center in X is going to deal with positioning the tube across the width of our bench. And as long as we reference the size X parameter of our bench, when we come in and control this guy mathematically, the tubes will all follow along and everything will still work correctly. So center in X, what if we were to take our size in X of the box and divide that by 2? Well, we've seen what that would do. That will center us up so that our tube is centered up on the edge. So if we were to take this and come back in by our radius, well, that would move us in so we're flush with the edge. So let's take this, which is currently a positive value, and subtract our radius 1 away from that. But being flush with the edge is kind of not aesthetically pleasing. It would be nice to have a little bit of overlap. So to compensate for that, I'm going to take our radius 1 and multiply that by 1.5. So that's going to take us in just inside the edge. So that's our bench box and our first tube. Let's now deal with getting this guy moved to the other side. So I'm going to right click on the output of the tube and wire into a transform SOP and enter to place that into the network. I'm going to rename this to second tube underscore xform. So we're going to be dealing with negative x. So if we were to take our translate x and subtract the entire width of our box, so that would be our bench box size in x. We'll move over to this side of the box and we're going to be offset by 1.5 of our radius this way. So we need to add to this 1.5 of our radius to go back to being center, and then 1.5 of our radius to get the same offset that we had over on the other side. So that's going to be 3.0. So I'm going to add 3.0 times our bench tube rad 1 parameter. So it's 3.0 times the bench tube's radius 1. And that will move us in to this side. So we've got the tube on this side, the tube on this side, and our box. So now let's merge all of these guys together. So I'm going to right click on the output of the box, create a new merge SOP, enter to select that, enter to drop it into the scene. And I'm going to name this to merge bench tubes and seat. Let's take the output of our bench tube, left click on that, wire him into the merge, and the output of our transform SOP, left click on that and wire him into the merge. Also, there we go. So now we have our bench, basic bench with tubes and a seat. And the beauty of this system is if you were to want to create a more detailed bench, like you could create an incredibly detailed bench as an asset, all you'd need to do is make sure that we match to these proportions and also have control over our size in X, which we are going to set up in the next video, I believe. We're going to deal with controlling that. And you could replace out this section of the network with your beautifully detailed bench, and everything else that occurs after this will just work.
Yeah, so you could say that this bench is a proof of concept.
Yeah, or just a prototype of a bench, and we can see it get copied around the stadium, and you can always go back and make alterations to sections of the network.
Proof of concept. We're proving that the network's going to handle getting this guy duplicated around and
I like
positioned
that. Proof
properly.
of concept sounds awesome. Fantastic. So we've got our proof of concept bench.
Okay. Our unit bench.
Our unit bench. And we need to deal with creating the points that we can copy this guy to.
Oh yeah, time for the good stuff.
So
back to the profile curve.
We've got our profile curve, and we have currently 3 points, and we need to create that point that's at negative 0.5 instead up here with a value of 1 in Y. And we can see that we've got point 0, point 1, we need to create him after point 1 before point 2. Point 0, point 1. So in between these two guys we need to create this new point. It's going to have 0 in X because he's going to still lie on that plane. He's going to have 1 in Y, so that he's up on this line. And as we've seen before, he's halfway between point 1 and point 2. Point 1 has a value of 0 in Z, and point 2 has a value of negative 1 in Z. So if we take negative 0.5, we're going to create a point up here on the top. Now, we've said that leaving that point in as we come down and create our profile curve, well, let's see what this happens. We translate back for our inner radius, we copy up, so we're going to get all those points copied, which is fantastic for copying the benches. But then we come through and we create our system for creating this profile curve, and that extra point is going to mess up our profile curve now. So we need to group this point, A, so that we can get access to copying the benches just to those points, but also so we can remove it so that it doesn't mess up our profile curve. So to do this, I'm going to take the profile curve, right-click on the output and wire it into a group SOP. Enter to accept that and enter to place this into the network. I'm going to rename this group SOP to group bench points. Let's bring our visibility down. We're going to be dealing with grouping points. The group name is going to be bench point group. And we're going to be grouping by a pattern, and the only point that we want to group is point 2, because that's the only point that is going to be used for copying benches to. So into the pattern parameter we can type 2, and that will simply grab point 2 into that group. So now we can come back down, and after we copy, so that we've got our profile curve copied up for all of our rows, we can delete out our bench point for the rest of our network, and then branch off and delete out everything but the bench point, so we can now work with copying our benches around.
Okay, let's go ahead and grab everything up underneath and just kind of push it down.
Sure. So I'm going to grab everything underneath our copy, and left-click drag to move it down. So if I right-click on the output of the copy, we can wire the copy into a delete SOP, and you'll notice any outputs that came out of the copy now come out of the delete into their relative branches. And I'm going to rename this delete to isolate profile curve. And to isolate the profile curve, we need to delete points, and the points we need to delete are our bench point group. And that'll delete out all of those points, so it's as if we'd never even created that point in the first place.
Yeah, look down the network.
everything works just as before, which is fantastic. So we've got this section of the network, this branch of the network working. If we middle click on the output of our copy into a new delete SOP and enter to place that into the network, we can now branch off in a new direction, isolate just those bench points we had, and then work with those to get our benches copied to the correct locations. So I'm going to rename this delete to isolate bench points. Again, we're going to be deleting points. We're going to have to reference our bench point group, but instead of deleting the bench point group, let's delete everything but the bench point group, and that will leave our points that are set up for our benches. Now, as we said before, if I come down and bring up and template our revolve, you can see these points are sitting on the edge of our row, and we need to get those to the center position. So let's take our delete that we've used to isolate those points, and I'm going to wire it into a transform SOP, and I'm going to rename this to rotate bench points xform. And we can see, if I was to rotate in Y, as I start rotating in Y, we arc round, and eventually we're going to hit the edge and be centered on the center of that edge.
You just mentioned the problem.
Exactly.
That's arc around.
If we're in the center, look at that, we're not sitting on the center of the benches because we've arced around. The way that the revolve works, it takes that original profile and it revolves through an arc. It just so happens that whenever we've created detail, that's sitting perfectly on the arc because of the way the revolve works, but in between we've now got straight edges as opposed to curved edges. So anywhere in between, if we were to just simply rotate, we're not going to sit where we want to sit. We've seen how to tackle that nicely over on the whiteboard. We simply rotate so that we do sit on this side, and then we can average the locations. We've also seen that we have 180 degrees going from this side through to here. So to find out the angle for one section, we can take 180 degrees and divide it by our number of columns. So let's set our rotate Y to 180 divided by our columns parameter that's up on our asset. And that will move us to sit perfectly on this edge. And now we can use the point SOP to take these guys, and if we average their location, it's as if we create straight lines between them and then find the center point, and that's going to be perfect for where we need to copy the benches to. So I'm going to middle click on the output of our delete and wire into a point SOP. And let's rename this guy to average positions. And I'm going to left click on the output of our transform SOP and wire that into the second input. Bring the visibility down and you see that we haven't changed from our first input. And that's because the positions of the points are being set equal to $tx, $ty, $tz. Well, what does that mean? Well, the point SOP takes the points that are coming in the first input, and they're going to be the points that we output from the bottom of the point SOP. And we've told them, keep your position, keep your existing position in X, Y, and Z. So point 0 comes through and he'll be in the same place through to point 4 being in the same place. But we've added our second input in, which means we can reference this in our expressions to change the positions of these first points that are coming through. And we saw how we could do that on the whiteboard by averaging the two positions. So we can take $tx and add to that $tx2. So that says, okay, point 0 coming in on the first input, he's going to have $tx. Let's reference the $tx of point 0 coming in on the second input. Point 0 on the second input's over here. Point 0 is here, so if we take those two positions, add them together, and take the result of that and divide it by 2, we're going to average the position in X. If we do that in Y and Z, we're going to average all of their positions. So $ty plus $ty2, all divided by 2. And $tz plus $tz2, all divided by 2. Now technically, we don't need to average the Y location because we know these guys sit on the same Y position, but just so that everything's nice and clean and just makes as much sense as possible, we're going to say we're averaging the positions, thus we're going to average X, Y, and Z. And we can see that by averaging, as opposed to rotating, we now get the center points exactly where we need them. And with those center points where we need them, we can take our bench and we can make a copy of this bench to each of those points. So I'm going to wire the output of our merge for our bench into a copy SOP. So I right click on the output and create a new copy SOP, enter to accept that, and enter to drop that into our network. And let's rename this guy to copy benches for rows. And we can wire our average positions, our points that we've just set up here, as the template for our copy. And that will create a copy of our bench to each of these points. But as noted on the whiteboard, the benches are set up and orientated such that they align with this particular axis. And we want to align with this axis. And we've seen to do that, we know how to calculate this axis. It's 180 divided by our number of columns. If we divide that number by 2, or take 90 divided by our number of columns, we're going to get this central axis. And if we rotate our benches while they're still centered up on the origin, we're going to rotate them around the middle point. And we can see that by rotating them around the middle point, they'd still be positioned correctly, and they'd be oriented correctly also. So I'm going to right click on the output of the merge and wire into a new transform SOP. And let's rename this to something like rotate bench for initial orientation. And set our rotate in Y to be 90 degrees divided by our columns parameter up on our asset. If we enter that, we can see we're now oriented correctly for that row. We've still got our width to deal with, and we'll deal with that in the next video, but we've got our benches positioned correctly for this first row and oriented correctly for this first row. And with that, that's actually going to wrap up everything I wanted to show in this video. Have you got anything you'd like to add?
No. Excellent. Very good. And with that, that wraps up this video. Thanks a lot.